So today we're graphing square root functions. A square root function is a function that contains an independent variable in the radicand. Y equals the square root of x is the simplest square root function. If you have to graph y equals the square root of x, you can create a table with the least value of x being 0. For real numbers, the value of the radicand cannot be negative, so the domain is limited to those values of x that make the radicand greater than or equal to 0. In this case, 0, substituting x for 0 will make y equal to 0. So the smallest value for x will be 0. If we substitute x with 0, then y would equal 0. If we substitute x with 1, y would equal 1. If we substitute x with 2, y would equal 1.4. And we're going to approximate the value to the 10th place. If we substitute x with 3, we get that y equals 1.7. We substitute x with 4, we get 2. We substitute x with 6, we get 2.4, and it goes on. If we plot these ordered pairs, we would plot 0, 0, 1, 1, 2 and 1.4, 3 and 1.7, 4 and 2. We can plot 6 and 2.4. And then we can graph these, plot them, and then connect them, join the points using a curve. If we have to find the domain of the function, we can set the function as greater than or equal to 0. Because remember that the radicand cannot be a negative number. If we solve this, minus 3, we can see that x is greater than or equal to negative 3. That means that the domain is the set of all those numbers greater than or equal to negative 3. This is the domain. If we have to find the domain of the function y equals 3 times the square root of 2x minus 8, we have to set the radicand as greater than or equal to 0. What do we have to do? Add 8 to both sides. 2x is greater than or equal to 8. Divide by 2 on both sides. X is greater than or equal to 4. That means that the domain for this function is the set of all those numbers greater than or equal to 4. For any positive number k, y equals the square root of x plus k translates the graph of y equals the square root of x up k units. So we have to graph y equals the square root of x plus 3 by translating the graph of y equals the square root of x. That means we're going to draw the same curve, but starting at y3. The same curve translated 3 units up. We have to graph the function of x equals the square root of x minus 4 by translating the graph the function of x equal the square root of x. Do we have to move up or down? We have to move down 4 units because this is minus 4. And it's exactly the same curve translated 4 units down. For any positive number h, y equals the square root of x plus h. translates the graph of y equals the square root of x to the left 8 units. So if it has a plus a number inside the radical, we're translating to the left. If it has a minus a number inside the radical, we're translating to the right. Right here in purple ink, if we have to graph the function x is equal to the square root of x plus 4 by translating the function of x equals the square root of x, that means we have to move the curve 4 units to the left. 1, 2, 3, 4. And we draw a curve. If we have to graph y equals the square root of x minus 3 by translating y equals the square root of x, then that means we have to move our graph 3 spaces to the right because there's a minus sign inside the radical. With the same curve, move to the right or to the left.